Section 12.3, we're going to look at something called a Taylor polynomial. First of all, I'd like to look at a factorial, which looks like a exclamation mark. And basically that means we're going to take that number and multiply everything going down from it. So if I have 4 factorial, that's 4 times 3 times 2 times 1. You can do this on your calculator. And let me pull up my calculator so you can see where that would be. I'm going to go here to the math menu, and then I'm going to have to go right to prob, since this is frequently used in probability, and then down here to option 4. And here I didn't actually put anything in front of that, so let's say 4 factorial. And again, if I did 4 times 3 times 2 times 1, I do get the same value. So you can do these on your calculator if you need a little help with it. All right, so let's start by looking at the Taylor polynomial for e to the x. Now do note here, these Taylor polynomials are going to be at x equals 0. We're going to write this as the sum from I equals 1 to n of the f, that little f with the I in parentheses, that means the ith derivative of f at 0 over I factorial times x to the I. And we'll talk more about why this works in a moment, but that will simplify to 1 over I factorial times x to the I. Now, we're going to do it of degree 5. So what that means is I'm going to go from 0 to 5. So that means I'm going to start at 0, and I'm going to go to 5. So using this little formula, I'm going to be plugging in these values for I. So I've got 0 factorial x to the 0, then 1 factorial x to the 1, 2 factorial x squared. Again, those factorials in the denominator. You'll notice I am adding all these terms up, and I ran out of room. So simplifying, then I get 1 plus x plus 1/2 x squared plus 1/6 x to the 3rd plus 1/24 x to the 4th plus 1 over 120 x to the 5th. So this would be my Taylor polynomial of degree 5. Now in this section for homework, sometimes we're going to want just that Taylor polynomial, but we are also sometimes going to use that to approximate values. So here I want to approximate e to the power of negative 0.02. So I'm going to take this Taylor polynomial I just found and replace x with negative 0.02. This is something that could be done without a calculator. It gets pretty messy, but it is possible. So again, this is another technique that was used for approximation before we had calculators. But since I have a calculator and I'm lazy, I took that, threw it in my calculator, and got out about 0.818730. And then I also checked with my calculator. I typed in e to the negative 0.02, and I got 0.8187308. That is a pretty darn close approximation, and that's a good thing. All right, so again, in this homework, we will be asked either for a Taylor polynomial or to be asked to use that to approximate. Now, this general formula for a Taylor polynomial, I will give you this, so you do not need to have it memorized. And again, this little f with this number in parentheses, that would be that derivative. So this is the second derivative, this is the third derivative, all the way up here to the nth derivative. Now, because these can get quite annoying if you have to go far, we are not going to go above degree 4. In fact, some of the time we might only do degree 3. So our formula will be f of 0 plus, that should say the first derivative, over 1 factorial times x, then the second derivative at 0 over 2 factorial times x squared, plus the third derivative at 0 over 3 factorial times x to the 3rd, plus the fourth derivative at 0 over 4 factorial times x to the 4th. All right, so I have my function here. It's the square root of x plus 1. And let's find that value at 0, which is 1. So what I then did is I found my first, second, third, and fourth derivatives. You'll notice I rewrote so that I could do it with a chain rule. The derivative of the inside is always going to be 1 to make life a little easier. And then once I had the derivative, I plugged in x equals 0 so that I could find those values. So I got 1/2, negative 1/4, 3 over 8 and negative 15 over 16, getting up to my fourth derivative at 0. And then I plugged those in. So I've got 1 plus 1/2, 1 factorial is 1 times x, plus negative 1/4, 2 factorial is 2 times x squared, plus, that's positive 3 over 8, 3 factorial is 6 times x cubed, plus negative 16, or 15 over 16 over 4 factorial is 24, x to the fourth, and then I just simplified those fractions. So this would be my Taylor polynomial of degree 4 at 0. Now, I can then use that to approximate. Here we were asked to approximate 0.9. Now be a little careful, that 0.9 is not necessarily my x value. I am basically going to solve my function equal to that to figure out what x is. And solving that, I get negative 0.1 for my x. So be a little bit careful, that number is not necessarily our x value. But I then plugged that in for my x. Now again, we could do that by hand. I am very lazy, so I did it on my calculator. And then once again, I did approximate 0.9 on my calculator just to make sure that these numbers were pretty close. And yeah, that is a pretty darn good approximation. Most of these I'm not going to be quite that close, but it should be pretty darn close. Let's do one more example of that. Here, let's do 1 over 1 minus x, and I'm going to rewrite that as 1 minus x to the negative 1 for simplicity. So again, I started by finding the initial function at 1, then I found my derivatives. I had to be a little bit more careful here. I did still use the chain rule, but the derivative of the inside was negative 1, so I had to be a little bit careful about my signs. And you'll notice I didn't fully simplify all these, because I then did also plug in 0 for x. And my first derivative was 1. My second derivative at 0 was 2. My third derivative at 0 was 6. And my fourth derivative at x was 24. I noted then, those are the same as those factorials. Those factorials are part of my problem, so I used that for simplicity. So again, f of 0 plus the first derivative at 0 over 1 factorial times x, plus the second derivative at 0 over 2 factorial times x squared, plus the third derivative at 0 over 3 factorial times x cubed, plus the fourth derivative at 0 over 4 factorial times x to the fourth. And again, because those were all factorials, they simplified, and I got 1 plus x squared plus x cubed plus x to the fourth as my Taylor polynomial. They don't all simplify that nicely, but this particular one did. Now again, we then also want it to approximate. Here I've got 1 over 1 over 0.98. Now again, I'm going to set that equal to my function to find x, because that 0.98 is not my x value. When I solved, I found that my x value is actually 0.02. So again, be a little bit careful when solving for that x value. But then I plugged that in for x. I chugged that through on my calculator to get that. And again, I then checked the 1 over 0.98 on my calculator, and those numbers are pretty close together. So I'm guessing my approximation is correct. Again, I use that calculator to at least make sure that my answer does make sense. So that is everything in section 12.3. So again, I will give you this general term. So again, we need to find the derivatives. We need to find then the derivatives at 0, at which point I can plug them in to my Taylor polynomial. And then if we approximate, I find the x value, and then I plug that x value into that Taylor polynomial.